Before we enter Phase 2, we would like to give some prerequisite information on the measurement and verification, or M&V, of ESPC projects. In many cases, it is the M&V requirements that differentiate ESPC from traditional contracting. The purpose of M&V is to assure that the ECMs are performing as guaranteed. As we mentioned, the contractor is paid from energy cost savings. Energy cost savings is defined in the ESPC regulation at 10 CFR 436.31. Energy cost savings is defined as a reduction in the cost of energy and related operation and maintenance expenses from a base cost established through a methodology set forth in an energy savings performance contract. The correct methodology for a particular project depends on the type of energy conservation measures, site-specific factors, and the allocation of risk in the contract. Thus, it is essential to the team's acquisition strategy to develop their M&V plan up front and to incorporate it where necessary in the contract. In this segment, we will discuss several M&V documents, explain the elements of M&V, describe M&V options and M&V methods, and identify the 6 steps of M&V. M&V is an integral part of any ESPC and plays a role when screening for projects, preparing an RFP, evaluating proposals, and verifying performance audits. Let's join Carver Hudson and the ESPC workshop for the M&V discussion.
Recently, guidelines were developed which provide the measurement strategies used for ESPC. First, the North American Energy Measurement and Verification Protocol was developed by public and private sector experts. It provides an overview of current M&V techniques, and it establishes a framework for verifying savings from energy conservation projects. Second, the FEMP M&V guidelines for federal energy projects is a specific application of the NEMVP to be used on federal sector projects. It assists federal procurement teams in choosing the most appropriate M&V option and method for specific projects. You'll learn what those methods and options are later on. A third guideline is being developed by the American Society of Heating, Refrigeration, and Air Conditioning Engineers, or ASHRAE. The proposed ASHRAE guideline for determining savings uses standards for measurement activities at a level of detail most appropriate for the M&V specialist. It's being developed by the ASHRAE Guideline Project Committee, or GPC-14P, and should be published sometime in 1998. For this course, we'll focus on the FEMP M&V guidelines. The FEMP M&V guidelines may be applied to all federal projects to develop site-specific M&V plans. The guidelines describe options and methods for estimating M&V savings and provide criteria for selecting the options and methods most appropriate to the project. I just want to let you know, you'll find in this program that some phases are more contracting and some are more technical. Most of this phase is very technical. Remember, when choosing the best M&V solution for your situation, remember that both parties must agree to the requirements for verifying savings. The protocol is designed to help achieve that agreement. The correct M&V method for each project is dependent on the contractual relationship, particularly the allocation of risk. Risk allocation between the government and the ESCO can be described in 2 broad categories. First, who is responsible for the performance of the ECM? Second, who is responsible for achieving long-term savings? Brad, can you clarify a typical risk allocation?
Sure. What I'd like to do is illustrate with a couple of simple examples. First of all, in the case of a lighting project, lights are either on or off. They're switched on or off by the occupants. In that case, we have an operational consideration. The ESCO has little, if any, control over when they're on, when they're off. There's little chance that the lights, the performance of the lights over time will deteriorate. So our main focus in determining whether the lights are saving energy is how many hours are they operating and who's got control over that? Well, the occupant. In this case, the occupant, the agency, assumes the risk because he has control of the operation. In a second case, if we're looking at a water chiller, now the occupant really, I mean, he has some control at various places around the building through the thermostats, But primarily we're concerned about the performance of the chiller. How much energy does it take to produce the necessary cooling to keep that building comfortable? This is in the control of the ESCO. He chooses the chiller. It has certain performance criteria, and he also is responsible normally for maintaining it. So here, we're not talking about an operational consideration, it's performance. The ESCO has control of it. The ESCO assumes the risk. Now that's provided that there aren't changes in conditions which are prescribed in 10 CFR 436-37, such as greater occupancy, the agency moves a bunch of computers in so that the loads in the building increase, that sort of thing. Those are changes to condition, and there would probably be a renegotiation of the contract required if that happens. But to recap, if it's a simple, like a lighting project, the agency or the occupants have control of the lights when they're on, when they're off. There's little chance of deterioration in performance. Then the agency is the one that assumes the risk, the occupant. In the case of a chiller, where the occupants have less control over the actual performance of the machine, then the ESCO assumes the responsibility.
Okay. So M&V procedures are designed to be flexible in evaluating energy savings and contain three elements: baseline, adjusted baseline, and measured performance. First, let's define these terms, starting with baseline. The baseline is the energy use prior to implementation of ECMs. It can be either measured or calculated. The baseline will be used throughout the contract. It contains all the relevant performance information. To determine the baseline, the team uses data from multiple sources. These sources include utility bills or metered data, occupancy rates, equipment schedules, and relevant weather data in relation to the energy conservation measures, ECMs. In some cases, the baseline may be adjusted to reflect changes in conditions from the initial baseline determination. Methods and procedures for adjusting the baseline are discussed in the FEMP M&V guidelines. The adjusted baseline is a calculated number and is derived using M&V guideline methodology. The adjusted baseline is the quantity used to compare with the actual performance of the ECMs to calculate energy savings. Measured performance is the measured and/or calculated performance or energy consumption of the ECMs on energy systems after ECM installation. The measured performance is determined through actual measurements taken at least annually throughout the contract. Measured performance is compared to the baseline to calculate savings and therefore the corresponding performance payment.
Finally, you must decide whether to use a baseline established by the government or established by the ESCO. There are benefits to each. If your agency has the capability to obtain information on your chosen technologies, you may want to establish your own baseline. On the other hand, if information is difficult to obtain with your agency's resources, you may opt for the ESCO to establish the baseline. The ESCO may select the best methods and procedures and use them to then establish the baseline. Remember, the government needs to know what the ESCO's approach is before award. The measurement and verification information found in this section may be familiar to the engineers watching, but it's probably new to most contracting officers. Understanding M&V, however, will prove to be a great benefit later in the ESPC process. To review the elements of M&V, turn to Phase 2 in your student manual and read the information found on pages 2-1 through 2-7. Please stop the tape. Each of the methods for determining energy savings use the same basic concept. That is, comparing the actual energy usage after the retrofit to what the usage would have been without the retrofit. Unfortunately, it's impossible to measure what the energy usage would have been. Therefore, it's impossible to measure energy savings. Instead, energy savings are determined based on assumptions about the baseline. The M&V guidelines contain several options for establishing energy savings. We'll go over each of them, but keep in mind, none of the options is better or worse than any other. Now let's go back to our panel discussion for more on M&V.
The first, option A, is designed for projects in which the performance potential needs to be verified but savings can be calculated based on stipulated operation values rather than directly measured. In other words, energy performance is measured. The actual operation of the retrofit is stipulated based on the engineer's judgment. Brad?
Yes, option A applies with ECMs, energy conservation measures, where the load is constant. Two examples of this would be lighting, and another one would be motors, constant load motors. In these cases, they're either switched on or they're off. And the energy use becomes a function of the operating hours. Performance, when the lights are installed, you want to verify that the lighting levels are as they're specified to be, and there's a one-time check to make sure that they're consuming the amount of power that they are specified to consume. Beyond that, it comes down to operating hours. Now, through some measurement, some collecting of data, you can establish what that schedule looks like and stipulate it. So it takes one of the variables out of the contract.
Thanks, Brad. The second option, option B, or retrofit isolation, is best suited for ECMs where performance and operation need to be measured. Under option B, system level of performance is measured continuously through the life of the contract. The measured consumption is compared to the baseline. Brad, can you give us a good example of an option B project?
Sure. I'll look at a chiller retrofit, a standalone chiller retrofit. In this case, we can measure the performance of that machine at various points, fully loaded and then partially loaded, and we get a fairly good idea if it meets the specifications or not, but we still don't know how many hours it's operating at each of those various points of loading. So in this case, we have to go beyond measuring the performance at certain points. We actually have to look at the performance of that machine over time and see how many hours it actually operates at those various conditions. So option A, we're looking at that one-time measurement, we're stipulating the hours of operation, and in option B, we're going a step further and actually looking at it over time.
Next, option C is geared toward whole building measurement. It can use utility bill analysis or hourly whole building measurements. Now, Brad, would you explain when you would choose option C?
Option C is very handy in situations where you have ECMs that you can't measure. Windows, insulation, that kind of thing. Anything having to do with the envelope. You can't measure the amount of energy that's consumed by that system. Therefore, you have to look at the whole building. You have to look at the energy consumed by the entire building. Another case would be if you have multiple ECMs, lots of energy conservation measures, and maybe one has an effect on the other. So if you measure each one, you still don't have the big picture. You have to look at the entire building, and that's what option C does.
Well, finally, option D uses whole building calibrated simulation. Now, Brad, can you tell us more about option D?
The last option, option D, is useful for new construction projects where there's nothing out there that you can measure right now. You can't go establish a baseline with your metering and monitoring equipment. The only way to establish a baseline is through computer simulation. That's the intent of option D. If, for example, you're looking at a new building, new construction project, and you're wondering, would it be cost effective for me to improve the efficiency of that chiller or that lighting system or that air handling system, what have you? Well, simulate the design, use a computer simulation to determine what the baseline would be, and then simulate that building with the energy improvements, and you can see what the difference would be. And quantify it in that way. And then, of course, once the building is built, then you can measure the new building after it's built as a way of, to some degree, verifying what the simulation results that you're working with.
The level of certainty and effort required to verify both the potential and the actual performance of an ECM will vary from project to project. When selecting the appropriate M&V option and method for your project, factor in the value of the proposed ECM in terms of projected savings, the complexity of each ECM, the number of interrelated ECMs at a single facility, the uncertainty of savings, and the allocation of risk between the agency and the ESCO. Also, when choosing the M&V option and method, remember that the information collected may be used for other purposes, such as commissioning, which we will cover later, system optimization, cost allocation among tenants, information for future projects, and research. There are 6 basic steps for measurement and verification for an energy savings project. 1. Establish the M&V option and method. 2. Prepare the site-specific M&V plan. 3. Define the baseline. 4. Monitor the installation of the ECMs. 5. Determine the post-installation savings. And 6. Perform periodic verification and reporting. They can be categorized into 3 groups: planning, implementation, and verification. Steps 1 and 2 are planning steps. They occur before the ECM's implementation. Steps 3 and 4 are implementation steps. Steps 5 and 6 are verification and reporting steps.
Before we go to the frequently asked questions segment, let's take a moment to review. In your student manual, read pages 2-7 through 2-15 to review the prerequisite M&V information. Now, please stop the tape.
What if savings are not achieved?
Well, it would depend on the circumstances. For example, did the building occupancy change? If there were more occupants in the building now than when the contractor or the ESCO determined the baseline, then there would be some renegotiation there. If the utility rates changed, same situation. There may be some renegotiation necessary to account for that. And in the FAR, or rather in the rule, it lists 7 or 8 items for which you can adjust the baseline. And you'll find that in your book under the legislation on page 71, a list of all those items.
Let me add another example to sort of illustrate a concern. What if energy savings is not realized? In the case of a project like the Ellis Island Statue of Liberty National Monument, they did an energy savings performance contract with lights, an energy management control system, and variable speed drives on a lot of the air handling systems. And it turned out the way there was 2 M&V approaches. One was looking at the utility bill as sort of a confirmation, and one was actually isolating the ECMs. When they looked at the utility bill, there was no savings. We looked into it. First thing, when you see there's no savings, you got to examine what's the cause. And it turned out they added 20% square footage. They've been doing reconstruction at that site. So from a utility bill perspective, there was no savings. But when we went in and we actually looked and did sort of the option A approach to the lighting, it was clear that the lighting energy savings was being achieved. So you really have to examine sort of find what the fault is and research it.
Yeah. If it happens to be the fault of the contractor, then you can adjust payments to that contractor. If he's 10% below, you might for the next month or so not pay him at all until you reach that new level of savings, and not bring him back up to that level until he's showed you that he is again achieving the savings that he guaranteed.
But the rule does say that if he does not achieve the savings and he is at fault, and there is no middle ground like this to give him a chance for a year or 2 to pick up on it, then he just doesn't get paid because that was the risk he took.
Brad, how do you know when you've collected enough data?
It all depends. It really does depend on the energy conservation measures. Some of them are very difficult to quantify, and you need lots of data, as Mike knows. You may find ECMs where you literally need 6 months of information. Data loggers out there collecting data for a number of months. In other cases, a couple of weeks. might be sufficient. Now, there are guidelines for this. In the FEMP guidelines, which you have, and in the NEMVP also, there are guidelines as to how much data, in terms of how many weeks or months of data do you need for particular ECMs. So as a guideline, or as guidance, those two documents should help you out a lot.
I heard you folks talking about the technical aspects of MNV, but what about cost? How does that factor into what technique you use on your measurement and verification plan? The cost of MNV.
You want just enough M&V, no more. There are cost guidelines in the NEMVP to give you some sense, some range of what the M&V costs might be for various ECMs. Again, it really depends to some degree on the layout of the electrical circuiting in the building. Where can you put your data loggers, things like that factor in, which is why the guidelines give you a range rather than a hard and fast number. But it is possible that you may be interested in implementing an ECM that cannot be measured without extreme cost, and for that reason you wouldn't be able to do it. That can happen, it's not likely. On the other hand, you could have the very simple situation if you have a separately metered building, all it is lights, you've already got the data. It's in your utility bill. No, you don't really need to go a whole lot farther. So it's going to run the full gamut.
I think we want to keep in mind that MNV can be very expensive, and you want to hit a balance. You don't want to spend $10 on MNV and only save $1 in energy savings. Right. So you have to hit a reasonable balance between the two.
Is there a rule of thumb percentage, like 1% of the savings or 10% of the savings, or the guidelines?
The only thing we've got is a little bit of evidence from some of the previous contracts, and these actually probably were, the data comes from projects before the MNV guidelines were in place, but typically what I've seen is relative to the installation and the investment in the equipment, the operating costs, if you will, including M&V, runs anywhere from 2 to 5% of that installation cost on an annual basis. So and that includes the M&V piece. And what we find is, particularly when the ESCOs are doing the baseline and doing the M&V, there's a motivation to keep that cost down, to be competitive in a competitive environment.
In relation to discussing the adjusted baseline, if both parties don't agree to that, how do you resolve that?
Do you mean in a situation where there's been a change and you want to renegotiate what the basic savings amount is?
Correct. If you have you were predicting a bad winter and you only had a mild winter, and the ESCO doesn't want to change the baseline, and the customer says, well, that didn't happen, so you need to adjust that.
Mm-hmm. Doug, there is a provision in the rule for weather where you can adjust. But what your question was, what if you can't agree?
Basically, the disputes clause or whatever in any contract would kick in. I think one of the things that's sort of an emerging thing is using alternative dispute resolution type of considerations, and there are mechanisms that we've been looking at to possibly invoke either in provisions of the contract where when you're doing the M&V site-specific plan, one of the things actually that's a component of that is to look at if you're doing an M&V approach, let's say that's a whole building where you might be using a statistical regression model. One of the things that we want before we sign the contract is the ESCO and us to agree and address what are those variables that we're going to be looking at, so that when we get to a situation where we've got a problem and the baseline is going, the adjustment to the baseline is significant, it's affecting the cash flow of this project, at least up front you've identified, here's the variables we expected to run into. I think it's just going to help you. But the reality is if you can't agree, it becomes an issue of dispute.
And that's nothing special to ESPC. That's basic contracting.
I'd be wise to hire a third-party engineering firm to come in and make an independent decision, and you agree up front that you will agree with that decision. And some ESCOs actually propose that. from the very beginning. They like to have a third party involved that's independent.
Okay, I have two questions. First, does the scope of the North American M&V protocol cover overseas properties? And the second questions I have is, are there any plans to ultimately adopt the protocol anytime in the future?
Sure, the NEMVP was drafted or written by a group including federal and state and private sector in this country, and Canadian and I think Mexico energy officials were involved also. And we would certainly encourage overseas sites to use the NEMVP or take parts of it and draft their own. But there's no reason that it couldn't be used overseas. And I'm sure it would get a good deal of support in those activities.
It's generally been adopted
It's my understanding that right now it's really the only, not the only document out there, but it's the leading document, and we're finding it has a great deal of acceptance in this country, in North America, and overseas. What we hear, I don't know how much it's been used over there yet, but certainly people do seem to be liking what they see, and they're embracing it.
One of the things that's interesting also, just in terms of the overseas adoption, I don't know about adopting it necessarily, but this protocol, it's available on the internet, and it's been translated into several languages, including Russian and several others. So
It's just not the type of document that would be restrictive geographically, based on the type of information included.
Most of our facilities just have one master meter, so we don't have a good control over individual buildings. And we do have projects on the backlog to individually meter buildings. Would we be better off to wait and include that under an ESPC plan then?
I would suggest you get the meters in as soon as you can. I mean, there are some cost impacts there as well. If it's going to cost you an arm and a leg to get those meters installed now, well, then that's one thing. But if you can get it done without great cost or through appropriations and start getting that information now, you'll have a much better baseline. You'll have more historical data to look at and establish your baseline. If you can't do that, by all means, do it when the project is implemented.
one of the things that typically goes along with one of these projects is that in operating and maintaining the equipment, that's considered part of the responsibility of the ESCO. Well, it's really expensive to have people on site, so almost because of the cost of data acquisition systems are coming down and fairly inexpensive now. For instance, the Statue of Liberty, they talked about putting an energy management control system. Yeah, that was something that they needed, but the other use of that particular device is they can monitor the runtime hours of motors, the lighting circuit, sample several, and determine exactly how the facility is being used. And that I think is really a feature that comes along with these types of projects. To be able to monitor the performance remotely, the ESCOs will put in direct digital control systems and monitor key aspects of your building. So you actually get the metering almost as a result of that. You might want to specify it, that I want to see what the energy use of the building is if you don't put it in advance.
We have a potential of having huge fluctuations in our population during the year. And I would think that that would lead us to have to adjust the baseline quite often. Is that something that we would normally do, or how would we handle that situation?
If you have fluctuations and they're significant, you'd want to make some adjustment for them. And if it affects the load, if you have an influx of people at certain times of the year, you'd want to look back and see if you can quantify how many people. Over time, over the years, if you have records to show month by month what the occupancy rate is, and compare that with your utility bills, there might be some correlation there. There is a way to average out those fluctuations so that when you establish a baseline, it's all built into the baseline. And that in the next year, and you may not really even care if it happens in any given month, depends on how you're measuring it. You may just care about the average for the year. But you need to take that into account somehow and discuss it and understand what those variables are, as Doug was suggesting earlier, so that you know you can go back and say, we made these several assumptions in determining this baseline, so that once the ECMs are installed, you can, if there are changes to that, you can understand why and how they might be different from the assumptions that you made.
One strategy I might suggest also is where, assuming you have some information, one of the mechanisms that's interesting about this type of contracting, where they're negotiated procurements, you basically can have the contractor propose to you an approach or solution. For instance, to say, if your particular operation, you know there's a dynamic in there, in the section in the RFP that says, please address to us how you would handle measurement and verification for this condition, and describe it. And the interesting thing is, when you look at the proposals, you'll see a breadth of skills in terms of, hey, you know what, I ran into a building like that 3 years ago. How did we handle that? And they may actually offer you solutions which, in the best value approach of negotiated procurement, may be what you're looking for. So that's another strategy you might use. If you don't have the data and somebody that knows statistics well or whatever, you might just throw up, here's the condition, describe to me how you would approach it, ESCO. And then that's where you can begin that risk discussion.
Should an agency negotiate a fixed energy rate with the ESCO?
The model solicitation we've produced actually suggests fixing the rate, primarily because utility rates are very hard to predict. The utility deregulation, everybody's saying the rates are going to go down. Well, everybody's speculating whether that's going to happen and when. The one thing about fixed rates, here's some of the advantages and disadvantages. The advantage is, if the rates go up, the contractor is not being compensated because of something that was completely out of both of our control. Actually, you get the benefit. And it's a predictable revenue stream. You know in 15 years, if you fix the rate, what's to be expected in terms of performing. If the rates go down, that's the risk the government takes. So that's the risk-sharing issue. One suggestion I want to offer that the industry has been recommending to us is look at the Department of Energy has these energy rates that are used for our own calculations of life cycle costs. That might be a way to do it too, where it actually builds in escalation rates based on the industry's past projections. Something like that might be used.
It's another reason to keep your utility rates fixed for the term of the contract. Keep them fixed, you're not going to have to deal with a lot of extraneous mathematics, and it can get very complicated. Keep it simple. The contractor knows what his cash flow is going to be, and the bank or the company that's loaning the money, they know what the cash flow is going to be, and everybody's more comfortable.
You were speaking of quantifying earlier. Can you quantify the performance of a piece of equipment as it is operating instead of using historical data?
Historical data, and if that means utility bills, that sort of information, or logs that the maintenance staff has kept up to date, or any information that they might have, historical information that they might have on the operation of the equipment, I would take that information and first of all verify that it is valid. We've seen sites where the facilities people have very good intentions, but perhaps they haven't calibrated the meters as regularly as you'd like to see. And if you're trying to establish a baseline, or even in pre-screening, you want to make sure that whatever information you get is valid, that it's been taken, that the meters are in calibration, that units are correct, that you're getting the right information. But if there is historical data, by all means, use it. Use as much of it as you can. Once you verify that it's good stuff, it's good information, it's accurate, then you should take advantage of it and use it. There may be some need to add to that with some real-time operating information beyond the historical.
I think it's important to note that this was introduced as a very technical part of the subject, but the procurement people need to be advised that the ease of your administration will be, particularly as it centers around the payments of savings to a contractor based on what you agree upon. It's very important to you now that this be accurate, or otherwise you shall pay for it later.
Yes, most of the discussions today have been about modifications to existing buildings. When you were presenting option D, you mentioned new construction. To what extent can you use ESCO contracting for contractors for new construction?
Yeah, I think I'm glad Brad brought that up and you asked the question. I would say that when they passed the statute, that was probably not the major intent of this legislation. The simulated approach in option D is a perfect application for new construction. As it turns out, the General Services Administration, working with the Department of Energy, has established a pilot in one of their facilities where what occurred was in the budget for that building, it was cut, and what resulted from the budget cut in the construction cost was all the energy efficient equipment that was proposed to be put in. What ESPC is being used in this pilot scenario is to use a partnership between the A&E that's designing the building and the construction contractor. They're putting back the energy efficient equipment, and the energy savings performance contract is being used to capitalize the differential cost, the difference in the equipment that would have been put in with the lower budget versus the energy efficient equipment. And the baseline, the simulated baseline, is being used to determine what the increased performance or energy efficiency of that building is as a result of that equipment. And that will be the payment stream back to this contractor. It's complicated, but it's an interesting approach.
Brad, you had mentioned using option A for simple lighting retrofit. How do you factor in the secondary effects to the HVAC system from that lighting retrofit, either decrease in the amount of cooling energy you need or increase in the amount of heating energy you need?
Normally you don't. And the M&V guidelines suggest that you do not enter into that level of complexity. There may be exceptions if the lighting loads are significant, very dense lighting loads, but in the guidelines you'll find that they recommend to not address those interactive effects between lighting and load.
A good example is the Forrestal building, the big lighting project. In fact, that was brought up in the proposals. Hey, how about we think it's going to reduce your cooling load 10% and increase the heating 5%. It was nixed. The payment for the Forrestal project is just for the lighting energy savings, although there's no question there was an effect there.
It adds to the complexity considerably.
Well, I would say it would have to be addressed because in some situations you could end up with an uncomfortable environment from a technical standpoint because you did reduce the amount of heat energy that's generated.
That is a case where clearly you have to use some caution, because if you're relying on the lights for some of your heat in the at the cooler times of the year, you may end up with a problem of being too cold when your lights are more efficient, not putting off as much heat through inefficiency. So that's a very, very good point.
This concludes our discussion of measurement and verification for ESPC projects. We'll use this information throughout the ESPC process, starting with Phase 2.